Hey everyone, welcome back to the channel. Today we are exploring one of the coolest friendships in science, electricity and magnetism. These two are basically physics BFFs. Electricity can produce magnetism, magnetism can create electricity, and whenever charges from one piece of matter interact with charges from another, you get both electric and magnetic forces at play. So let's break this down in the simplest and funniest way possible. First, what exactly is electricity? Think of electricity as the interaction between electric charges. Every atom contains protons and electrons, and these tiny particles come with built-in charges. Protons are positive, electrons are negative, and they behave exactly like the friend group that can't stay calm, always attracting or repelling something. According to the law of electric charges, like charges repel and unlike charges attract. Two positives push each other away, two negatives push away, but a positive and a negative snap together instantly. Coulomb's law tells us how strong the electric force is. It depends on two things: how big the charges are and how close they are. The larger the charges and the smaller the distance, the stronger the force. So yes, even electric charges believe in the closer you are, the more drama there is. Static electricity is when charges simply build up on an object instead of flowing. The classic example is rubbing a balloon on your hair. Some electrons move from your hair to the balloon, making your hair positively charged and the balloon negatively charged. Suddenly your hair stands up like it's having a bad day. But these charges don't stay forever. They eventually escape in something called electric discharge. If you've ever touched a metal doorknob and felt a mini zap, that's discharge. A dramatic, large-scale version of this. Lightning, literally nature's biggest electric tantrum. Now let's talk about electric current. Current electricity is when charges actually move continuously. Current tells us how much charge flows per second and is measured in amperes. There are two types of current. Direct current, or DC, flows in one direction only. It's very disciplined. Batteries give you DC. Alternating current, or AC, keeps switching direction constantly, like someone who changes their mind every 5 seconds. Homes run on AC because it travels well over long distances. Now, electricity needs the right materials to move. Conductors are materials that allow electricity to travel through them easily. Metals like copper and aluminum, water with dissolved salts, graphite, and even your own body. Insulators are materials that resist electric flow: rubber, glass, plastic, wood, paper, and air. These are the nabro, not today materials for electricity. To make electricity useful, we create circuits. A circuit has an energy source like a battery, wires that carry current, a load like a bulb or motor that uses electric energy, and a switch that opens or closes the path. If the circuit is closed, current flows. If the circuit is open, the flow stops, like Wi-Fi being switched off at the worst moment. There are two popular ways to connect devices in a circuit. In a series circuit, everything is connected in one single path. That means if one device stops working, the whole thing stops, like a chain of people who all fall if one loses balance. In a parallel circuit, each device gets its own pathway. If one fails, the others keep working peacefully, like a group project where one person does nothing but everyone still passes. Then comes the legendary Ohm's law. V equals IR, voltage equals current times resistance. If you want to find current, divide voltage by resistance. If you want resistance, divide voltage by current. It's one simple equation that basically controls how electricity behaves in circuits. Now let's jump into magnetism. Magnetism is a force that attracts or repels certain materials like iron. Every magnet has two poles, north and south, and the magnetic force is strongest at the poles. Like poles repel each other, and unlike poles attract. So magnets behave almost like electric charges, but with their own twist. Around every magnet there is a magnetic field, an invisible region where magnetic forces act. You can imagine it like invisible curved lines going from the North Pole to the South Pole. Fun fact: Earth itself is a giant magnet. That's why a compass needle always points north-south. The Earth's magnetic field also protects us from harmful particles from space. Without it, life would be in big trouble. So yes, Earth literally acts like a superhero shield. Now comes the big connection between electricity and magnetism, electromagnetism. Hans Christian Ørsted discovered that when current flows through a wire, it creates a magnetic field around the wire. This was a huge discovery. If you take a wire, wrap it into coils around an iron rod, and pass current through it, the rod becomes a magnet, an electromagnet. The more loops you add, the stronger the magnet becomes. Electromagnets are everywhere, in motors, speakers, TVs, doorbells, trains, and so many devices you use daily. Finally, Faraday's law of electromagnetic induction ties everything together beautifully. When you move a conductor through a magnetic field, or when you change the magnetic field around it, electricity is generated. This is how most of the electricity in your home is produced. Power plants rotate giant coils inside magnetic fields to create electric current, and that current is what eventually reaches your lights, fans, and chargers. Magnetism. And that's the incredible story of electricity and magnetism, how charges move, how magnets pull and push, how electricity flows, how circuits work, how magnets are created from electric current, and how electricity is generated using magnetic fields. These two forces literally shape the modern world. If you enjoyed this and learned something new, make sure to like the video, drop a comment, and subscribe for more fun and easy science explanations.